This senior year project, our group invested our time into a laser engraver or a CO2 laser cutter. The first, the features that we wished to implement was changing the laser engraver's traditional design to a vertical orientation, including a smaller floor space, reduced costs, and auto-feeding stock material for larger products. Our project roles were split up as Evan was in charge of construction, coding, and electrical. Austin was the project leader, construction, electrical, hardware, and cost analysis, while Jonathan was in charge of commercial applications, market potential, and coding. Our electrical diagram was construction around the idea of implementing an Arduino to control majority of the electronic devices. Um, Instead of using a CNC driver or a CNC shield, as they know, we decided to use stepper motor drivers as they allowed for better micro-step controllers to help drive the stepper motors. Everything was powered by a 12-volt power supply. That besides core components such as the laser controls and um, auxiliary systems for the laser controller, such as air pumps and water cooling, but they were still controlled through relays on their Arduino. The limit switches were used to communicate when to stop and start the motors, and the user interface was a 3.5-inch touchscreen. Our software was actually implemented using open source Gerbil, but here is a rough diagram on how the code was processed. G code is the standard implementation of machining code um, that gets compiled on computers that tells CNC machines, whether it be routers, lathes, or laser engravers, when to cut, what position, etc. It is fed into the program, and the data is broken down into processing commands that the machine then executes. Our original implementation was to break down G code into partitions to allow the project to cut multiple partitions per se to be more user friendly, but we ran out of time, so we ended up using open source GRBL as our primary output. The reason why we ran out of time is we had a lot of design flaws, and trying to mount the system in a vertical, we had a fork belt systems. So we decided to use ACME screws. Our original ACME screws was 8 millimeters, but because of the vertical length was more than 4 feet, we had whipping issues. Um, so we decided to ditch the 8 millimeter ACME screws and decided to replace it with 3/8 4-star ACME screws. But the problem with that is that the blocks that are available for 3/8 4 starts are only these PLA blocks that cause jamming. In the process of changing the diameter size of the shaft, we messed up our alignments, so we had to um, change and remill some of the parts to correct the alignment issues. Here's the machine deconstructed because we had to change out the shafts at the very end. Our original testing electronics have to be removed because the product's built-in parts. What you're about to see is the core of the machine, as it's easier to align things in a metal frame and then prop it up. Um, but we'll go over some of the fixes that we had some of the problems. Here are the two axes and the the belt drive system. I mean, not the belt drive system, the ACME drive system. We fixed the alignment issue and replaced the pillow block that was jamming. It actually works pretty well now, but we haven't been able to hook up the electronics to test out at full acceleration. Um, but we think what the problem was the two sides were getting out of sync, and it was causing a jamming on the PLA block. But we managed to change out all three axes. Well, there's two axes, but three drive shafts. Two on the x-axis. Here's the one underneath. But the problem is because it's mounted at the very limit. When we increased the diameter, it pushed down the pillow block, thus hitting the the y-axis. So we had to remachine it and move down the aluminum extrusion to make room for um to make room in line for the gantry block. Here you can see the laser system and the mirror setup. I have the mirrors removed right now because they're fragile. They're silicon gold covered and they're very prone to dust and vapor scratches, so we have them stored away currently, along with electronics. And that is it.